As a science student, anyone could ask during badminton how much force you applied for this smash. Here, deriving the force of a badminton smash involves considering the principle of physics, specifically those related to projectile motion and the transfer of kinetic energy. The force can be analyzed in terms of the speed of the shuttlecock just before impact and the time it takes for the shuttlecock to come to rest. Here is a simplified explanation of the derivation. Number 1. Speed of shuttlecock before impact. The speed of the shuttlecock just before impact is a crucial factor. Let's denote this speed as v, small v. Number 2. Deceleration during impact. The shuttlecock comes to rest during the impact with the racket. The deceleration can be determined based on the change in velocity and the time of impact. Number 3. Force during impact. The force during impact can be calculated using Newton's second law, F is equal to ma, where m is the mass of the shuttlecock. Number 4. Kinetic energy. The kinetic energy just before impact is given by Ke is equal to half mv square. Number 5. Work energy principle. The work done during impact is equal to the change in kinetic energy. Work is equal to delta Ke. Number 6. Force and distance. The work done can also be expressed as the product of force and the distance over which the force is applied. Work is equal to Ft, where d is the distance over which the force is applied. Number 7. Equating and solving. Equate the work done to the change in kinetic energy and solve for force. Fd is equal to delta Ke. This is a simplified derivation, and in practice, various factors such as shuttlecock design, string tension of the racket, the player technique come into play, additionally accounting for air resistance and the other real world complexity would require a more detailed and sophisticated analysis. Let's consider a simplified real life example of a badminton smash force. Suppose we have a badminton player hitting a shuttlecock with a racket. The shuttlecock speed just before impact is approx 60 meter per second. Number 1. Deceleration during impact. Let's assume the shuttlecock comes to rest during impact. So the change in velocity is v. The time of impact is very short. Let's say 0.01 second. So A is equal to delta V by delta T is equal to minus 60 meter per second divided by 0.01 second is equal to minus 6000 meter per second square. The negative sign indicates the deceleration is in the opposite direction to the initial velocity. In this case, as the shuttlecock is coming to rest during the impact, the acceleration is against the original motion, so it is assigned a negative value. Number 2. Force during impact. Using F is equal to ma, where m is the mass of the shuttlecock, let's say 0.005 kg. F is equal to 0.005 kg into minus 6000 meter per second square is equal to minus 30 Newton. The negative sign indicates that the force is acting in the opposite direction to the initial velocity. Number 3. Work energy principle. Calculate the kinetic energy just before impact. Ke is equal to half mv square. So 1 by 2 into 0.005 kg into 60 meter per second square is equal to 9 joule. Sorry, 60 meter per second whole square is equal to 9 joule. Number 4. Force and distance. Equate the work done Fd to the change in kinetic energy. Fd is equal to delta Ke. F is equal to minus 30 Newton, and we need to find out D is equal to minus 9 joule. Solving for D, we find D is equal to 0.3 meters. So, in this example, the force during the impact is negative because it acts in the opposite direction to the initial velocity of the shuttlecock. The distance over which the force is applied is approximate 0.3 meter. This is a simplified scenario, and real life values would depend on various factors including the specific equipment, technique, condition, air resistance. My point is, it's important to note that obtaining precise values may be challenging without specific measurement and data related to the equipment and the player's technique. Professional studies or experimental setup may provide more accurate insight into the force involved in a badminton smash. Thank you for utilizing your time and learning something new.